Today, I want to talk about how to find an inverse function and what that actually means. So let's get into it. So let's say we have a function f of x equals 3x plus 2. To find the inverse of this, our first step is changing this to y equals 3x plus 2. Then we're going to swap the x's and the y's. So we're going to get x equals 3y plus 2. Now from here, we're going to solve for y. So we subtract 2 and we get 3y equals x minus 2. Then we can divide by 3 and we get y equals x minus 2 divided by 3. Let's try this out. So what does this mean? Actually, hold on. Before we try it out, let's denote this. This is our inverse. That's denoted with f to the power of negative 1 of x. And that will equal x minus 2 over 3, right? So now let's try putting in a number to f of x, because what an inverse is if we put a number into our function, we'll get a number out. If we take that number we get out of the function and we put that into the inverse, we'll get our original number back. So let's say our original number is 1. Let's put it into this function. We get 3 plus 2, that's 5. Then let's come back down here to our inverse function, and let's put 5 into here. We get 5 minus 2, that's 3, divided by 3, that's 1, okay? So that shows it works. Let's do another example with a linear function, and then we'll look at one slightly more complicated example. So let's say we have f of x equals 7x minus 5, right? So we start off, once again, by saying y equals 7x minus 5. Then we swap the x's and y's, and we get x equals 7y minus 5, and we solve for y. So start with adding 5, and we get 7y equals x plus 5, and then we can divide by 7, and we get y equals x plus 5 over 7. And then let's denote it with our inverse symbol. So f to the power of negative 1 of x equals x plus 5 divided by 7. So now, once again, let's test it out. Let's say we put 2 into here. We put 2, we get 14 minus 5. 14 minus 5 is 9. And then we take 9, let's put it down in here. 9 plus 5, that's 14, divided by 7, that's 2. And that's our original number, so that shows it does work. Now let's think about something like f of x equals x squared, right? Is there an inverse to this? Is there an inverse to f of x equals x squared? Well, let's recall that the graph will look like that, right? It'll be like a parabola, right? That's not a great drawing, but it'll look something like that. And the issue that we have is this graph is not one-to-one. So essentially, the graph fails the horizontal line test, right? And when the graph fails the horizontal line test, that means essentially what that's telling us is if there's an x over here that makes this y, and there's an x over here that makes that same y value, right? One y value corresponds to 2 different x values, right? If you have that, there's no inverse, okay? But what we can do to make it so we do have an inverse is we can change this we can restrict the interval to 0 and to infinity, right? So now we're getting rid of the negatives. So now graph will just look something like that, okay? So now what we can do is we can observe what happens if we were to, can we take the inverse of this? And the answer is yes, we can. The inverse is just square root, right? So we'll get, f prime, so let's do it the same way we did before. We'll get y equals x squared, right? Then we take the square root, then we swap, and we get x equals y squared. Then we take the square root, and we'll get y equals square root of x, right? That's our inverse, right? And we can see, right, if we think about, let's put 2 into here, we'll get 4, right? We put 4 into here, and we get 2 back. So that does in fact work. Now let's think about what does that actually look like graphically. What does it look like graphically to take an inverse? Well, here we have our graph, and let's draw the line x equals y, or something like that, right? If we reflect this line if we reflect this graph over the line x equals y, we will end up with this graph. And that is the same thing as the square root of x, right? So essentially what happens graphically when we take an inverse is we're reflecting it over the y equals x line, right? So now what we can do is let's erase this and let's instead restrict this to negative infinity, comma, 0, right? And let me erase this. So now we're going to solve it the same way. We'll get y equals x squared. We swap them, and we get x equals y squared. Solve for y, and we get y equals square root of x. Except this time, since we restricted our domain here, it's going to be the negative square root. Because whenever we take square root, we're either going to have positive or negative. But since in our case, since we're restricting the domain like this, it's just going to be negative since we're working with inverses. So now let's think about it. Let's say we put negative 5 into here, right? We'll get 25, right? We put 25 into here, we'll get 5 times negative 1. That's negative 5, right? So that does in fact work. And then once again, let's think about, okay, here is our x squared restricted on this interval, right? Or it looks something like that. And then we'll draw this line. And then once again, if we were to reflect it over this, we would get something that looks like that, okay? And that is the graph of negative square root of x, right? Thank you for watching. Let me know if I said anything wrong or if you have anything additional to add. Have a great day.